In today's ever-evolving software landscape, error handling remains a persistent challenge for developers. Conventional methods often lead to unpredictable runtime errors and inefficient error management, hindering the reliability of applications. This is where Rust's innovative approach shines. By mastering Rust's error handling techniques, developers can write robust, reliable software that gracefully recovers from issues, ensuring a seamless user experience and reduced downtime. Building upon our understanding of error handling challenges, let's delve into the core issues that developers frequently encounter. First, unexpected runtime errors can emerge at the worst times, disrupting processes and impacting user experience. Second, error propagation can be inefficient with traditional methods, often requiring verbose code that is prone to omissions. Finally, these methods can lack reliability, making it difficult to assure stakeholders of consistent software behavior. We'll soon explore how Rust's model addresses these problems effectively, providing a path towards more robust applications. Continuing from where we left off, let's explore how Rust fundamentally transforms error management. At the heart of Rust's error handling are the result and option types. These types provide a structured way to manage errors, reducing the unpredictability and verbosity commonly associated with traditional methods. By effectively using these types, you can construct more resilient applications, ensuring that errors are caught and managed decisively. Welcome to a new era of robust software development with Rust. Now let's dive into an example that illustrates how to use Rust's result type to effectively manage errors. Here, we define a function called divide that demonstrates handling divisions by zero and other scenarios gracefully. This approach ensures robust error management and software reliability. Building on our previous discussion of Rust result type, let's now examine some best practices and common pitfalls when handling errors. One vital technique is using Rust's question mark operator, which streamlines error propagation, making your code cleaner and more efficient. This operator replaces verbose match statements for error handling within functions. Furthermore, while unwrap may seem convenient, it introduces risk by potentially causing panics if an error occurs. Instead, leverage Rust pattern matching to gracefully handle complex error scenarios, enhancing your application's reliability. Let's wrap up our journey into Rust's error handling. We've explored the power of the result and option types, the elegance of the question mark operator, and the importance of avoiding the unwrap function. Mastering these tools allows you to transform your Rust applications into reliable and robust software. We encourage you to start applying these strategies in your projects. We'd love to hear about your experiences or any questions you have, so please drop a comment below.